column where you get that, like, you can split the data up in a more a cleaner way. We're going to talk about that. I have another slide here because predicate pushdown can be amazing in that case, because if you have a subpartition, what it allows you to do is it allows you to avoid reading in a big chunk of data that you don't need to read in. And it just ignores that folder because it gives you another layer of folders, and it says, oh, our query doesn't want that folder because it's filtering it out, and we don't even have to read in the data. We can just ignore it. And so that's where subpartitioning can be very, very powerful in avoiding large cloud bills. There is some trade-offs there, and like I think that there are definitely cases where I've seen subpartitions used incorrectly as well. But that's generally speaking, this is how I would imagine things would work with large cloud bills. Those are going to be your big ways that big symptoms or big causes of large cloud bills that you can probably fix. Let's talk a little bit about why subpartitions work. So imagine you have a table here. We're calling this table notifications. And then this table has three partitions, or it has a subpartition on channel. So it has a partition on date and a partition on channel. And you'll see, okay, we have three folders here. We have a date. We have one for January 1st, January 1st, January 1st for email, SMS, and push. And one of the things you'll see is we have a query down here, select star from notifications, where date is January 1st and channel equals SMS. So you'll see when this query runs in Spark, it will skip this folder and it will not read in this data set at all. So you don't pay the IO cost, where like if this wasn't subpartitioned, right, and say we were only partitioned on date, then what would happen is we would read in all three of these data sets and then throw all of them away that didn't match SMS. And then that would be extra IO cost that we wouldn't want to pay. This is a great way to avoid that IO cost by like just immediately filtering it out, because we know that none of the data in this folder is going to be valid. And so that is definitely one of the powerful things that you can do with subpartitioning, especially if you have a subpartition that is kind of immediately filtering it out, because we know that none of the data in this folder is going to be valid. And so that is definitely one of the powerful things that you can do with subpartitioning, especially if you have a subpartition that is kind of low cardinality. Like I generally think of, like, if you have a subpartition, it should be like, it's similar to enums. Remember how we were talking about enums before, where enums are like it should be like 30 or less. If you have like if it's like where you have the number of unique values is like 30 or less, and usually it's like 5 or less, but there are some edges where there's a little bit more. But generally speaking, it should be like 30 or less values. This is where like country is always the one that's like, some people are like, yeah, we should subpartition on country, and it's like, nah, dude. Don't do it. Like, country is going to be annoying. So because if you do country, then you're going to have like 200 tasks. And that's super annoying. So you want it to be more of a low cardinality field that you and one that people use in their filters a lot, right? Because one of the things that was really powerful about this subpartition in notifications is one of these notifications types is a lot bigger than the others, right? Push is 2 orders of magnitude bigger than SMS. So it's like if you didn't subpartition and you wanted to run a query that looked at SMS, you would be reading in all the data and then throwing 99% of it away and paying that IO cost because you read it in. You read it off of S3 and just threw it away and just wasted it, right? And that's where subpartitioning can be very powerful in giving you more of an IO efficiency gain that I highly recommend looking into on, especially if you have any big fact data. That's where you're going to see some really big gains here. So let's talk a little bit about how these things are connected, actually, because IO, compute, and storage are not independent. Where like if you have bigger tables that are stored in bigger places and you read in more data, like you're gonna have more I/O, and so storage and I/O are obviously connected, and compute is also connected to these two, right? So like what I was saying before, large I/O and compute are connected a lot because if you're scanning too much data, you're going to be reading in a lot more data, and then you're going to be running a lot more. That's going to tie up your Spark executors for a longer period of time because that I/O time is just like expensive. So you want to make sure that you are not doing that. Sampling is another great option here. Besides cumulative tables, sampling, predicate pushdown, all that stuff. Also, make sure that you're like in your UDFs, you don't have any n squared algorithms. In that case, that's where you have like loops inside of loops. If you have nested loops in your algorithms, you want to like make sure to kind of avoid those. So there are some small edge cases where that's the only way to solve the problem, but like 99 times out of 100 that I've seen a nested loop in production, it's tech debt. It's not like, oh yeah, that guy just had the best option. He knew exactly what he was doing and he thought through everything. No, he was just trying to solve the problem in the quickest way he thought of. So I/O and storage are correlated because if you're not leveraging Parquet, the file format the best, then you're going to get a lot more I/O costs because your storage tables are not compressed enough. And if you can compress your data tables with Parquet, then your I/O is less because when you read in the data, it's compressed, and then it only becomes uncompressed when you are already in you're in the executor and you're already on the machine. So then you don't have to worry about you don't have to worry about the I/O cost at that point because the I/O is already done and because it's compressed already. And then obviously the other one is duplicative data models, just like what I said earlier, where it's like if you have 7 different definitions for the same thing, you're going to get a lot of extra I/O, a lot of extra storage. A lot of extras. It's a lot of so that's why like data modeling is so important, right? And so critical. Okay, now this is one of the things that I find a little bit more near and dear to my heart because I think this is probably the most impactful work that you can do as a data engineer. And it makes your job easier, and it makes things more efficient, and the maintenance is better. It's like you win in every single way, and there's no way that you lose. That's the part that is so crazy about solving this problem here. And like I said, if you can solve these problems, this is where you're gonna really find a lot of impact as a data engineer. And this is like solving these problems is also like where I got really good performance reviews at Airbnb and also all sorts of stuff like that as well. And so let's dig a little bit into this. So it's very common, especially as an organization gets bigger and bigger and they have more and more needs for data, that they don't have enough data engineers or they don't have enough data infrastructure. And like what ends up happening is like different aspects of the company are like, well, I need this data set and I just need it as quickly as I can get it, right? And then they don't really care as much about the quality, and they don't really care as much about like if other people have already created it, they might search real quick to see, and then if it's there, great. If not, they'll go make it themselves, and then they'll keep doing that. So this work is complicated because of the fact that one, when people do these multiple sources and they have multiple pipelines that are producing the same thing, they might have different variations of the same definition. So usually that means that you have to convince somebody that their definition is wrong because, or maybe not wrong, but at least kind of not correct. And that is going to can be tricky sometimes because sometimes even people who are not data engineers are kind of married to the data that they created. And they're like, no, this is the most correct way to do it. And so you want to get all these stakeholders in a room. So like, for example, for me, when I was like trying to solve this, like many different definitions of availability at Airbnb, like I had to get so many people in rooms and just talk it out and see like how we could solve this problem and going forward. And like both like, and the thing that was crazy about the way that I solved that problem was that we didn't end up picking any of the ones that already existed. We created a new definition, and then everyone agreed on that definition because they were like, yeah, that's the most correct definition. So sometimes that's the other thing about these multiple sources of truth is that they can all be wrong, or they can all have have problems as well, and that like there's actually another path forward that might be the most correct or the most efficient or the best. And so just because there's multiple sources of truth doesn't necessarily mean that one of them is, you know, quote unquote, the truth. That there's actually potentially room for improvements on all of it. And so a big thing to look at here is you want to document all the sources of truth that you can find. This is a big thing. I remember I had this spreadsheet at Airbnb that had like, it had like 30 or 40 tables in it. And like, I was like, if we can just consolidate, all of these tables can go away and we don't need any of them. And we can go from 40 tables to 4 and it would be better. It'd be a lot better. And that was the vision I sold my manager on. And I'm like, it's going to be so much better. And you need to document these things. It's tricky though, because of the fact that like one, people can name a table whatever they want. So it can be tricky to even necessarily find all the sources of truth. That's why, like, generally speaking, you don't find all the sources of truth via code search or via like grep or however technical way you want to do it. That can be a good way to get a good like fundamental start. But like, you really do want to talk with all the relevant business people, all the relevant people who like in all the areas of the business that might be using this data, because then you could uncover some really funky table names, things that you didn't even consider. Someone might have named their table QQXXLLL_W, and they're like, "Yep, that's availability," and it's like, "Okay, bro, okay, it's availability, I guess, right?" And anyways, you can't just rely on like searching the code base to find these tables. You need to talk conversations. It's important, and these conversations are also important anyways because it can help you understand like why they're using this data, and also understanding maybe the pain that they're having with this data or the lack of completeness or the difficulty or like all sorts of other things that you also want to pick up, right? Where like if you're part of the combined track, yesterday we were talking a lot about being a product manager. And this is a very relevant place to be here where like if you're building a pipeline, you want to be a data product manager where like you want to understand end to end how to delight your customers. Where a big part of that is completeness, another part is quality, another part is just refresh, freshness, quality, completeness, ease of use. All of those things are very important. And then also, if you take a pipeline off of someone's plate, they'll love you forever because then they're like, wow, I don't have to manage this beast anymore, and you will just manage it all for me. Like, thank you. So like that's why you also get a lot of claps and a lot of kudos for doing this as well. Because like in my case at Airbnb, there was like, okay, there was 7 different pipelines at least of generating different availability definitions, and then we turned it into one that we owned, and then it was like, okay, all those other pipelines that people were using we don't need anymore. And so that was another way to get a lot of kudos, a lot of respect, right? Is you're deleting work for people and deleting maintenance for other people. It can be tricky because sometimes it's like you're deleting maintenance for them, but you're putting more maintenance on yourself. So you want to like have a good balance of all that stuff. Obviously, you don't want to try to be a superhero. And then after you have all the needs and you have taken in all the pain and you've documented all of the discrepancies and all of the different sources of truth, that's when you want to build a new spec. And you want to build out the spec of the new pipeline that you want to build that's going to consolidate all of these things and be the new path forward that then you can talk to all the stakeholders about and be like, this is what we're going to go to. We're going to migrate to this. It's going to save you all this pain. Can you agree to it? And you want them to agree to it before you build the spec or before you start writing the code, because they might not agree to it. And like if they don't agree to it, then the problem is then like if they don't migrate, then a lot of your work is for nothing, because then they're still going to be using their own other definition, and then like all of that hard work of consolidating definitions is just dead. So it's all about getting that stakeholder buy-in, making sure that everyone's on the same page. Most of the time it's easy. Sometimes it's a little bit harder, but most of the time people are like grateful that you're doing it. So those are the 3 steps. Like, and all of that's a conversational thing, not very technical. Actually, it's very human, very empathetic, very product managery, right? Remember, I was saying, talk with all of the stakeholders, code search for similar names, like, you might want to grep for availability or something like that. And then you can also like potentially, if your company's really ahead of the game, they might have lineage. So then you can like go up to the source data. Because a lot of times, even if you have different definitions of something, they all read from the same source, or at least some of the same sources. So then you can find like the most raw log data or the most raw like data base snapshots, and those tables are gonna like the downstream of those tables are gonna be the definition tables that you're looking for, and that can be another way to find that stuff. Not very many companies have lineage though. Lineage is like kind of a new thing. I think that's going to be in the future. I think that's like going to be a good thing. That's one of the things that have you heard about Microsoft Fabric? I've heard that Fabric gives you that like out of the box. So if you just like use Fabric, then you get lineage for everything, and like that's cool. I like lineage. I think that like being able to see where data comes from is very powerful, and it allows you to do a lot of this good work as you kind of go forward with stuff. So definitely do that. Okay. Another thing that you want to do when you're like consolidating all these sources of truth is understanding like how it got here, because there's more problems here than just the fact that there's 7 data tables. Like there's other problems here that are also important to talk about and also important to bring up. For example, one of the things that can happen in a lot of these cases is you can have organizational problems where what actually happens, why there's multiple sources of truth, is one team doesn't trust another team to deliver, and so they just go and build it themselves. And it's like, why is that the solution, right? And it's like when that's where trust is super important, where you need to have trust between teams. Otherwise, like you're gonna have you're gonna have tech debt like this come up all the time. You have an ownership problem as well. Like for example, the team that should own this doesn't have the bandwidth to own it. So another team's like, okay, fine, we have a little bit of spare bandwidth, so we're gonna take it on, and that could be another kind of problem. But then they aren't the right team to own it because they actually don't have enough of the business domain to actually do a good job. So that's like usually that's more like a staffing problem where they should probably move one engineer to the other team so that then they can own that data set, which is very hard to do, by the way. Then you have technical. Technical would be like, okay, the team that should own this doesn't have the technical skills to own it, and then one of the teams that we have does have the technical skills. A lot of these are a combination of organizational and ownership and technical, right? Technical and skills are the same way. And obviously there's going to be a long tail of other reasons why we have duplicative data sets potentially coming up. But the whole thing about this and why you need to have these conversations, especially if you're like going to become a data leader, is if you can solve the organizational problem, if you can solve the trust problem and the ownership problem, then you stop the bleeding. You stop this problem from proliferating. And then you can get people to trust each other more. And then you can get more consolidated data sets that way. And then less maintenance ownership problem. Then you stop the bleeding. You stop this problem from proliferating. And then you can get people to trust each other more. And then you can get more consolidated data. Data sets that way, and then less maintenance, more efficient. Awesome, right? It's really good. And then like another thing that's super important is like working with these stakeholders to understand what the ownership model should look like, and also like how changes should be incorporated. Like if a model does need updates later on, like how who's going to drive that and who's going to build that out, right? And really hammering that down so that people in these other teams can trust that this data set will not just serve them after it's migrated, but that it will serve them in the future as well. And that could be another great way to build trust and to build just to build a lot of like rapport and to make people really like you as well, because you're taking something off of their plate and also guaranteeing to them that it will be managed in the future as well. That's awesome. That's like you're taking work from them immediately and future work. So like that's a lot of love, it's a lot of love. So remember to spread the love around. I love specs. Pipeline specs are so great, right? And that's what I was saying earlier. Got to build a spec, get all the needs, get everyone to sign off, and then because once they sign off and you have like a signature from them, or you have like they said this was good, then that is like when it comes time for them to actually move and migrate their downstream pipelines, like you can kind of bully them into doing it because you're like, yo, dude, you said you were going to do it. And because migrations are so painful, they're always so painful, and like having a document like this could be very helpful in getting people to actually do it. Let's talk about a little bit about different helpful in getting people to actually do it. Let's talk about a little bit about the different models for fixing tech debt, of like kind of the team ways of fixing tech debt that I've seen. These are essentially the three that I've seen, where you have the first one is called like fix as you go. It's also called like boy scouting. It's also called like a bunch of things like that. But it's like mostly like when you're shipping new features, fix the tech debt as you go. And it's an interesting model. We're going to talk about the pros and cons here in a second. Then you have like allocate a portion of time each quarter. So a lot of times, this is what Airbnb did. Was the second one. It's called Tech Excellence Week, which was the last week of the quarter. The last week of every quarter, we just did not work on new features. We only worked on cleaning up tech debt. And amazing, by the way. I love it. Loved it so much. And then the last one, this is the way that it worked at Netflix, was instead you have the on-call person focus on tech debt, because they get slapped in the face every day with the tech debt because they have to fix the on-call problems and to deal with the maintenance themselves. So then we're like, okay, on-call person, just if you're dealing with the maintenance already and you're unblocking things, why don't you not just unblock but also fix things? So you get kind of both in that way. But these three methods have their kind of pros and cons. All right. Obviously, fix as you go. The biggest pro here is like it's not very structured, and like there isn't much incremental burden. Like you're not taking away from very much else. I think the con here for this model is that like it sounds too good to be true a little bit. Where it's like, oh yeah, as you're coding, just fix the tech debt. It's almost like as you're shipping features, fix the tech debt, right? It's like almost like as you're flying the plane, fix the plane. And it's like, I don't know about that, fam. I don't know if that's like an actual viable model or not. If it is, cool. If not, like, I don't. I haven't ever seen seen it work in practice. All right. I mean, that's what Facebook was all about, and Facebook freaking was a mess. In terms of tech debt, Facebook was by far the biggest of the messes. So then you have the allocate dedicated time each quarter, right? You actually fix things in big bursts. It's great. One of the problems with this, though, I've found is that like people essentially, if you do have that dedicated time at the end of the quarter, you don't have the as you go fixes, and a lot of times you get like you get this like tech debt line, and then it's like cliff, and then build up and cliff, right? And it's like a crazy and like so at the end of the second to the last week of the quarter, there's a lot more tech debt in the code base, right? And then and you're not like it's almost like saying like, oh, I'm gonna save up all my teeth brushing, and I'm just gonna brush one time for 90 minutes at the end of the quarter, and like I mean, I don't know if that's how it actually works, but that's generally speaking, that's how I've seen it work. The other minus here is then people during that week, they don't have time to help stakeholders or to ship other features or other things. Like it comes at a pretty heavy cost for that week. I mean, you spend a month a year working just on tech debt, which is a significant amount of time that you could be using to spend other things, kind of like the opportunity cost. Having the on-call person do tech debt, the cool thing about that is that they are very aware of what the most urgent tech debt things are, because those things are slapping them in the face, because they're like, wow, this is failing, everything's on fire, and then they have to get their fire extinguisher out, and then they like try to fix stuff, right? I don't know, like one of the things I've noticed with this model is that like some people don't actually do it. I think that's one of the things I like about the dedicated week, as opposed to doing on-call person do tech debt, is the dedicated week is like everybody is doing tech debt that week, so you can kind of like there's this expectation that you all ship something, that you all clean stuff up, and that like you're gonna hold each other accountable. I found with when you say the on-call person needs to do tech debt, that they don't actually do it. That like I would say only like half the people actually do it. And that was actually something that frustrated me a lot when I worked at Netflix, because I was like, yo, dude, like if this is our model, like why aren't we cleaning stuff up? Why aren't you actually dedicating the time to that? And like a lot of times it would be they would want to spend that time working on new features or working on other stuff, right? And working on the things that are going to like, get them promoted. Because a lot of times tech debt stuff is not as visible, and so it gets deprioritized. And that's why I really do like the dedicated time each quarter, because then it's like, well, it's not as visible, but we're all going to work on it together at the same time. And then it's like, because it's kind of a team effort in that way, like it takes a village to tackle tech debt. And so those are the three models. Obviously, I biased y'all into saying which one I like the most, but I also think that the one that I like the most is the heaviest. It's the one that takes up the most time. It's the one that the way I think about it is it's the one that really takes it seriously, though. It doesn't just treat it like a secondary priority or like something that I'll get around to it if I can, right? It actually treats it as like, oh, we're going to block out time for this every quarter. So definitely try out all three. Tell me how it goes. Like if y'all can figure out how to get the fix as you go to work, I'd love it. I think that like I want to hear the success stories there, because like if that actually works, I think that I would like I think that would that's why I would want to do it, but I just don't think that it's realistic. Okay, let's talk about the data migration model. models, and then we will be almost to the runbooks part of this presentation. So essentially, there are two ways to go when you're migrating things. And I have a good story here because Airbnb changed their mind on this, which was so crazy. So if you're building a new data model, so in that example I was talking about earlier where we like built a spec and we got all the stakeholders sign off and we build a pipeline and we backfill the pipeline and we have a pipeline running in production. And then there is still that time between when you have that pipeline running in production and when other people migrate and they move, they depend on your data instead of the old data. There's like there's that time and there's like these parallel pipelines that both need to run. And one of the things about that is it's kind of expensive because then you're essentially paying 2x the cost of that pipeline for the duration of the migration. And that's like painful. And one of the things I noticed is that like when that happened, so initially the migrations I was working on at Airbnb, like when we made a new pipeline, it would take like 6 months for people to migrate. And then we just have 2 pipelines for 6 months. And then like sometimes it was like, is this even better? Like we're just adding another pipeline and we're holding on to both for 6 months. And this was actually a very common problem at Airbnb in 2021, where they were like, and eventually leadership came out and they said like, y'all are being too cautious. Like if things break, and people need to migrate. Because the problem is like everyone is being too cautious about breaking other people's pipelines or making other people's data delayed. And they didn't drop the tables or stop the legacy or the deprecated pipelines soon enough. And so what ended up happening later on, they were essentially like, you give them a month. If they don't migrate in a month, you start breaking stuff. That's essentially what they changed their mind, right? So that we don't have this like crazy long period of time where like the migration takes forever and people are just deep prioritizing moving the tables and backfilling and all that stuff because it's not fun. It's not fun. Migrating data is not fun. It's literally the least fun part of data engineering, all right? And it's like the most boring, least fun part of data engineering. So like I get why people don't do it. And so that's why like they only want to do it if they have to. And the way that you force them to do it is you delete the old pipeline and you make it so that their pipeline just doesn't run anymore because now their pipeline can't run because the upstream data doesn't exist. And the only way that they can get their pipeline to run again is by migrating. And that's why there's this the new one is called the bull in a china shop approach, where it's like, okay, once the new pipeline is up and running, like might as well migrate things. So like the way I did it when I was looking at like pricing and availability stuff was I was like, okay, we're gonna move any of the ML stuff, any of the expensive things that like if they broke and were delayed, then we're going to migrate those. And then once those are migrated, everybody else can just break and then they can migrate as soon as they can, right? And then they can just get their stuff to migrate because it doesn't matter that much, right? Because if it's delayed by a week, it still doesn't matter that much because their data set isn't that high impact anyway. And it's actually more impactful on the tech debt buildup and like on my own team's well-being to have 2 pipelines running in parallel for n number of months. So this is something that like I found very interesting, and I was very grateful that Airbnb changed their policy on this because freaking that first one was so painful. Where it was like essentially how it worked is like it was like 3 months where they run in parallel, and then after 3 months you rename you keep them both running in parallel, but the deprecated table you rename to like table _ do not use, and then you have it run for another couple months, and then drop it off at that point. And I was always like, dude, like these zombie tables just need to freaking die, man. Like why aren't these dying, right? And so definitely they both have their benefits and risks though, because the cautious approach. The thing about it is though, is that's a very it's a very accommodating way of doing data migrations, because if you just break stuff, the thing is like the other team is gonna be like, hey, you just put work on my plate. Like, why are you doing that? Why are you being a dick? Why you putting work on my plate? You don't want that, right? So, but like they learned that that's actually the better way to go. That like it's because it's usually not that much work to migrate. So let's talk a little bit about on-call, proper on-call response. responsibilities. So there's a couple things here that I want to talk about. So one is around set up proper expectations with your stakeholders. I think this is the most important part of on-call because if you can get this right, then your on-call will usually be a breeze. Because at least like when I was working at Airbnb originally, the expectation was that any on-call bug was going to be troubleshooted in 4 hours. And I did that for 6 months and I was like, I'm not doing this. Like, I'm not. 4 hours is stupid because then it's like if it fails at midnight, I have to troubleshoot by 4 a.m. Like, no, like I'm not doing this. And I changed it from 4 hours and I was like, you know what we're doing? We're doing 24 hours. That's what we're doing. And like, there was initially pushback because they were like, why are you making it worse? Why can't you do that? I'm like, because 4 hours freaking sucks. Like, and like, I don't want to have to wake up in the middle of the night and like, it's bad for my mental health and bad for my well-being. And it makes me hate my job. And like, and the thing, but also I told them that, but also another angle from it is that like, it makes no impact on the downstream. There's actually no impact really on the downstream unless the data is more than a day delayed. So like, that's, I think, good enough. And that's where you can have some really good conversations with your stakeholders. And the data engineer before you might have been crazy and done things in a way that like wasn't sustainable for you. And you might want to reset those expectations. And don't think like the expectations, the on-call expectations going into the job are what they have to be forever. Like it is within your power to make changes to that. The other big thing, document every failure and bug. You'll usually get an email from Airflow or an email from your job orchestrator if something breaks. Make sure to document it and put it in some sort of Google Doc so that you can keep track of all the failures so that you can find the problem children so that like your on-call can get smoother and smoother and smoother. And obviously you have like on-call handoff, which is where that's where usually on-call lasts a week and then you'll pass it to another person and then that person will, and then you have to give them all the context of like anything that is currently broken or things that broke over that week. And then that's usually like a 20, 30-minute meeting to sync up with people to get them to be ready for their on-call rotation. Okay, runbooks. Let's talk about runbooks. Runbooks a little bit, and we'll have a little bit of time to maybe create a little bit of a runbook. So complex pipelines need runbooks. Not every pipeline needs runbooks. You only need runbooks if like there's pipelines that have like a lot of inputs or they have outputs that are used by a lot of teams or they have a lot of complicated logic or a lot of data quality checks or like, things like that. Those are going to be the big things that you need in the runbook. And I think one of the things that's important here to differentiate is what's the difference between a runbook and a spec, because they are similar. And like some people actually say that they're the same and the runbook it should be in the spec and that like the runbook is just like an evolving part of the spec. So that's a big thing to remember. So the big things that you want to put in the runbook, primary and secondary owners. This is whether this goes in the runbook or the spec is like here or there. Usually that's in the spec. It can be in the runbook too. And that's going to be like essentially the primary owner is like who you tap if you're on call and a pipeline breaks and you don't know how to troubleshoot it. The primary owner is who you tap. And if they're on vacation, you tap the secondary owner. And if they're on vacation, like you freak out. and like a lot of times there isn't a secondary owner, and that can be a problem as well. Because I found that big tech doesn't do a good job at allocating 2 engineers for every pipeline, but that could be a thing. Another very important part of this is listing all the upstream owners, because one of the most common things that happens in data pipelines is the upstream data quality checks fail. And if you have upstream data quality checks fail, then you need to talk with those teams and be like, yo, your data sucks, fix it. And you want this to be teams, not individuals. The main reason for that is that team ownership fluctuates less than individual ownership. Because reorgs happen less often than people leaving the company, people entering and leaving the company. So it's better to actually have the contact point be a team than to have the contact point be an individual, because then at least like that, because that person might leave the company, and then you're screwed because you have no idea who like they are going to go to. So that's a big thing that I would imagine. And like, but even still, you can have reorgs that happen, and that team identifier might also be kind of bogus. So you want to be careful there. Another big thing here is common issues. So this is usually part of like the common issues is something that gets filled out over time, that usually the on-call person should be taking some of, like, if they're copying and looking at all those stack traces and failures that are happening, they should describe what happens and then the common way to troubleshoot it, right? And the common process to troubleshoot it, assuming that they can't fix it more long term, right? They can't, like, it's like just kind of a fundamental nature of the data as opposed to something that is like a bug, right? Where there are pipelines that are like that, like where you have like just like, especially like I know like scraping pipelines, if you're like scraping the web or whatever, you're gonna have a lot of common issues that like just happen because you don't have control of the source data. Then you have critical downstream owners. These are the people that you need to talk to. These people are going to be the people who, like, especially, you don't need to like document all your downstream owners. Like, you just need to document the ones that matter the most, right? For me, it was like smart pricing was the big one. That was like the ML model downstream, where it's like I knew if the pricing data was delayed, I had to talk with smart pricing quickly, just so that they were aware that like the pipeline was gonna be kicking back up and that I was troubleshooting it and figuring out what was going on. Last but not least is SLAs and agreements. So SLAs here is service level agreement, which is kind of duplicative here. SLAs and agreements are both agreements. And in this case, this is like, usually this is a number of hours, sometimes a number of days, number of hours or days. SLAs and agreements. So SLAs here is service level agreement, which is kind of duplicative here. SLAs and agreements are both agreements. And in this case, this is like, usually this is a number of hours, sometimes a number of days, number of hours or days after midnight for that day when the data is expected to arrive. And this is the agreement essentially between you and your stakeholders that says, okay, the data's not late until it's been this many hours after midnight. And that's going to be how you can kind of prevent a lot of your stakeholder questions from getting out of hand, is by because they're not going to be like, hey, why is it late? And then you're like, it's actually not late yet. It's going to be late in like 5 hours. So don't quit pinging me right now. So that's a thing to remember as you're kind of like going through this stuff. So these are the kind of the critical aspects of a runbook. And if you can have all these things in one doc, then you're going to be in a good spot. There is stuff that's a pain, right? But here's an example, I think will kind of give you a better kind of view of what I mean by how runbooks can be helpful. So you have over here on the left, you have kind of your upstream owners, right? So you have like owned by Joe Mama, the monetization team. He owns coupons and credits. And then Henry on the finance team owns revenue. And then Karen on the customer service team owns the customer service data. And then you have your pipeline. And then these are your output data sets. And then these are your downstream consumers that you want to talk to if this stuff breaks, right? And some of the times, like depending on how mature your data infrastructure is, some of the stuff can be completely automated so that these people will actually be aware of a delay or aware of a breakage without you having to contact them, which is great. But like if it's a very long delay, they're going to ping you and be like, why is the data late? Like, why haven't you troubleshooted this, right? And so you want to be able to have a good conversation and a good communication with that person as well. So that you can have a kind of a picture in your mind of, okay, this is the person that I need to talk to. And generally speaking, when you're building these pipelines, this is just another part of this process that I find to be very valuable, which is not quite as technical, but is a good part of this process as well, is you should have a regularly recurring meeting with everybody on both sides of this. So for example, in this case, I would probably have 3, maybe quarterly or monthly or quarterly one-on-ones with Joe Mama, Henry, and Karen, and then also with experimentation and pricing teams, customer service team, and efficiency team. I would have at least a quarterly, if not a monthly one-on-one with each of those teams, so that we can just be all on the same page. And then also just to understand like where they're trying to go and if we can improve some of these data sets to make them better, so that like you get like, it's great because then in those cases, you just get a way better connection with all of your stakeholders and you're just more integrated in the business overall. And you get a nice benefit from this of like, hey, we are your stakeholders will be nicer to you when there's problems because like you actually showed that you care about investing in the relationship over the long run. So it makes your life easier because then you're like, oh, like because I ran into this problem a long time, especially like early in my career when I was on call, was that like I would have stakeholders downstream who like were just like unnamed, right? Or like I just didn't even have a face to put on this stakeholder because it was just like a lot of stakeholders or a lot of people, right? And then there's just like, I don't even know, I'm making unknown people angry by delaying their data sets. And so like, and I was always, that kind of stressed me out. And so I found that like you definitely want to do relationship building with all of your upstream and all of your downstream consumers as a data engineer, because then like you're going to just catch things so much better, and it solves the other problems as well. It solves those duplicative data modeling problems. It solves like so much of the other kind of pieces of the puzzle. So we're going to go create a new doc here and then call this runbook for Exactly Inc. growth pipeline. Obviously, I'm a startup, so like I don't really have stakeholders, but we're going to pretend that I do have stakeholders. So in this case, what I want to say here's you usually want like a title, right? We'll call this on-call runbook for Exactly Inc. growth pipeline. Okay, so we have like our upstream data sets, and this is going to be like events. We'll say like website events, and then we have user exports. Then we have downstream consumers. We have experimentation platform, and we have dashboards. We'll say both like that, right? User database exports. So these are going to be our two kind of different ways of doing things, right? And so we remember saying I was listing my upstream and downstream data sets, right? And then in here we have like common anomalies, right? Or like sometimes referrer is null too much. This is fixed downstream, but we are alerted about it because it messes with the metrics, right? Something like that, because you can also have like data quality checks that are non-blocking, right? But they alert you because like they want to let you know that like you might need to talk with the dashboard users or the experimentation platform. And then you have like your user database, export might fail to be extracted on a given day. When this happens, export as soon as possible and just use use yesterday's. That's actually what it is. When this happens, just use yesterday's export for today. Something like that, right? Depending on like how reliable your infrastructure is. Obviously, this isn't idempotent and I hate it, but like that might be what your runbook is as a company, right? And so this is the idea, right? So you have like your common issues, like, and you probably want to call this like common issues, right? And then this is like bolded and like big, right? And then like obviously you have a primary owner, This is gonna be Zach. Secondary owner is Lulu. Right, and then we have well, there was some more pieces of this, right? We have the run books, right? So upstream owners, common issues, critical data, and then SLAs and agreements, right? So let's put that in here. So we can say SLAs. This is bigger. And then in this case, this is the data should land 4 hours after a UTC midnight or something like that, right? So Obviously, these run books, you're probably like, Zach, this is like the most ugly run book I've ever seen you write in your entire career. And you're kind of right about that. But the idea here, right, is now if someone goes to this pipeline and then they're like, oh, like I see this like refer anomaly, and then it's like, boom, done, right? But then it's like, okay, and then you want to question like, okay, if that's the case, maybe we need to remove that check and just and make it so it's like a higher signal to noise ratio where like the actual alerts are that way. But it's kind of hard to do that over the long run, like of just actually like fixing all your data quality checks, and like some of them are going to be noisy sometimes. But that's kind of the idea, right? And this is obviously I expect a lot more out of y'all because you're gonna like hopefully create a kind of a pipeline spec that is if you're in the combined group, you're lucky because you already created a spec that has a pipeline. But like if not, if you're like in the infrastructure group, then you need to also create just like a pipeline that describes things with inputs and outputs, and then it can also describe potential common issues and SLAs, so that this is going to be your homework for this week. And it's done in groups though, so you don't have to like it's a lot. I'm actually asking for quite a bit, especially if you're if you didn't do the analytics homework in week 3, then this is going to be a significant amount of work.
Congrats on getting to the end of the day 2 lecture. If you like this channel and like this bootcamp, make sure to like, comment, and subscribe, and share this content with your friends. I'm so happy that you're taking this time to invest in your knowledge and getting better at data. See you at the next one.
Like so much of the other kind of pieces of the puzzle. So we're going to go create a new doc here and then call this runbook for Exactly Inc. growth pipeline. Obviously, I'm a startup, so like I don't really have stakeholders, but we're gonna pretend that I do have stakeholders. So in this case, what we're gonna say here is you usually want like a title, right? We'll call this on-call runbook for Exactly Inc. growth pipeline. Okay, so we have like our upstream data sets, and this is gonna be like events. We'll say like website events, and then we have user exports. Then we have downstream consumers. We have experimentation platform, and we have dashboards. See both like that, right? User database exports. So these are gonna be our two kind of different ways of doing things, right? And so this is our, we remember I was listing my upstream and downstream data sets, right? And then in here we have like common anomalies, right? Or like sometimes refer is null too much. This is fixed downstream, but we are alerted about it because it messes with the metrics, right? Something like that. Because you can also have like data quality checks that are non-blocking, right? But they alert you because like they want to let you know that like you might need to talk with the dashboard users or the experimentation platform. And then you have like your user database, export might fail to be extracted on a given day. When this happens, export as soon as possible and just use tomorrow's, or no, use yesterday's. That's actually it is. When this happens, just use yesterday's export for today, something like that, right? Depending on like how reliable your infrastructure is. Obviously, this isn't idempotent, and I hate it, but like that might be what your runbook is as a company, right? And so this is the idea, right? So you have like your common issues, like you probably want to call this like common issues, right? And then this is like bolded and like big, right? And then like obviously you have a primary owner. This is gonna be Zach. Secondary owner is Lulu, right? And then we have well, there was some more pieces of this, right? We have the runbooks, right? So primary upstream owners, common issues, critical data, and then SLAs and agreements, right? So let's put that in here. So we can say SLAs. It's bigger. Then in this case, this is the data should land 4 hours after UTC midnight or something like that, right? So obviously, these runbooks, you're probably like, Zach, this is like the most ugly runbook I've ever seen you write in your entire career. And you're kind of right about that. But the idea here, right, is now if someone goes to this pipeline and then they're like, oh, like I see this like refer anomaly, and then it's like, boom, done, right? But then it's like, okay, and then you want to question like, okay, if that's the case, maybe we need to remove that check and just and make it so it's like a higher signal to noise ratio where like the actual alerts are that way. But it's kind of hard to do that over the long run, like of just actually like fixing all your data quality checks. And like some of them are going to be noisy sometimes. But that's kind of the idea, right? And this is obviously I expect a lot more out of y'all because you're going to like hopefully create a kind of a pipeline spec that is, if you're in the combined group, you're lucky because you already created a spec that has a pipeline. But like if not, if you're like in the infrastructure group, then you need to also create just like a pipeline that describes things with inputs and outputs, and then it can also describe potential common issues and SLAs, so that this is going to be your homework for this week. And it's done in groups though, so you don't have to like it's a lot. I'm actually asking for quite a bit, especially if you didn't do the analytics homework in week 3, then this is going to be a significant amount of work.
Congrats on getting to the end of the day 2 lecture. If you like this channel and like this bootcamp, make sure to like, comment, and subscribe, and share this content with your friends. I'm so happy that you're taking this time to invest in your knowledge and getting better at data. See you at the next one.
like so much of the other kind of, and then SLAs and agreements, right? So